Hello and welcome to yet another video. As you can see, I've pulled the electronics assembly off of the AMC 325 that's giving us some problems. We know from the previous videos this phase does not work anymore. It's essentially an open circuit all the time. No longer switching. Visual inspection shows all the MOSFETs look fine on both the front and the back sides. We can't really see the diodes, but we can do a diode check on them. That's why I've got this meter here. I'm using this El Cheapo because it's got a better LCD display than my current meter there. So what you do is you just put it in diode check mode, and we're going to go on, this is the positive bus. So if I touch each phase, I should see around 0.3 millivolts on all the phases. They should all be similar, and they are. And if I were to reverse it, the leads, it should be open circuit for every one of them. And that's what we're looking for on these phases. If it was actually shorted, then we would have problems. It would be tripping out with a current error and all kinds of stuff. It would make horrible noises. There's some videos of ones that had a short and they make horrible squealing noises. But this is checking the backside ones now. And so we're in the same ballpark, around 290, 0.29 volts for each of them. And then if we flip polarity here, we should get open circuits for everybody. So that's telling me that the gate driver has died in this thing. So unfortunately, that's like the hardest part to get out, because I have to remove the fan assembly and I have to remove the heatsink assembly from the heat spreaders, because this is that blown up stage where it's got the FETs that are exposed. And if I go like this, you can see that's the gate driver inside, and it kind of like lives inside of there. Well, that's that way, right? So the only way to get to it is to pull the heatsink off. And the problem with that is they've got 4 big hex bolts that hold the heat sink in to the heat spreaders, and they're really hard to get out because they've Loctited them. And sometimes I actually break the bolt off inside the aluminum, and that's really, really hard to fix. I end up having to drill it out, and then, you know, it's just a nightmare. So hopefully everything comes apart real nice and easy, and I don't end up breaking any of the bolts off inside of it. But yeah, everything's pointing to that gate driver being dead. If we wanted to do some swaptronics to figure out if it is in fact the gate driver, they're all identical. So not only are they identical, but they're like symmetric, so you can actually put them in either direction, doesn't matter. And you just take this off, and this is a socket too. That's the only difference between them, is they have different length cables to get all the way back out to here, right? But if you really wanted to do some swaptronics, you could take it all apart and then move that gate driver to, say, the middle phase or to the end phase, and then put it back together and then run it and find that, oh yeah, that phase no longer works anymore and this phase now works. So you've now verified that it is definitely the gate driver. Off camera, I don't show it. Well, I can show you. Like, you can come in here. The gate driver is hooked up, so we can actually go to the gate of these FETs and then check it, and there's no shorts. So it's not like the gate driver is just shorted completely. So it is still, it's an open circuit essentially because it's off. But that means that sometimes the gate driver, when it fails, it shorts it out. So it's going to be a pretty simple failure. Typically on the gate driver board, it's these are the 2 push-pull transistors on each side that actually drive the whole assembly. Everything else is just signal conditioning and taking the isolation. This little orange block here is a transformer, and they do a little push-pull converter on it. And if you look down in here, there's a bunch of, these are all the diodes that do the bridge rectification, and there's a little zener across there to keep the voltage from spiking up too high, and everything else is just drivers to make these guys switch. So we probably lost one of those parts. One of those transistors has died, or one of the support components has died, and it's taken out the board. Usually it's probably one of the diodes. I don't know. We'll have to take it apart and find out, because if one of the diodes on here has failed, it shorts out the secondary on one side of the transformer, and that kills the whole board. Like the whole board won't work because it's too much load on the other side and it can't switch anymore. So my guess is something like that. If it looks really bad like this one, where this got exposed to 150 volts and it just killed everything on this side, I think I've got spare ones. It might be quicker to just swap in a known good working one and get this puppy back up and running. And like this one came out of a bad one, and when I get some spare time, which I never have spare time, I can go back and actually repair these. If you go look on the website, there is one that was so extensively destroyed, but I like replaced every part on it and well, I think every part on one whole side, and rebuilt the entire thing, including adding little jumper bodge wires to actually fix the traces that got smoked. But yeah, that was a pretty extreme one. At the time, I didn't have any spare ones, so anytime these AMC 325s or 320s come up on eBay, I try to snap them up because they just don't make them anymore, and the parts are really hard to find. Like everything on here is pretty much obsolete. I mean, this was made in '93 or '94. What did it say? Oh yeah, it's the sticker says 1994, so it's 2016 now. So yeah, they're pretty old. So the parts are all obsolete. But anyways, I won't do that tonight because it's getting late. Tomorrow hopefully I can get this heatsink off without breaking anything. But that is the plan. Anyways, thanks for watching.